Alright, now let's do an example of how to find the sum of a series, a geometric series if possible. So we want to find the sum of these two series, right? So one is given us in summation notation, the other one is giving us the first few terms. So part A, they give us the common ratio, right? So the common ratio is negative 1/3, right? So R equals negative 1/3. This is a geometric series, you could tell, and it's an infinite series because it goes off to infinity, and the common ratio is negative 1/3. Now, if we take the absolute value of R, we see that that is less than 1, right? So 1/3 is less than 1, right? So we can more succinctly write it this way. So that means we can use the formula A1 divided by 1 minus R to find the sum of the series. Since it is convergent, so now the first term is going to be what? Well, when I equals 1, so the first term is 5. And then 1 minus R, so that's going to be 1 minus negative 1/3. Right? And so that's going to be 5 over 1 plus 1/3, right? So that's going to be 1 1/3. And so 1 1/3 is the same as 4/3, which is equal to 5 times 3/4, which is going to be 15/4, which is going to equal 3 3/4. So the sum is 3 3/4. All right, not bad. All right, so now, what about part B? Let's look at part B. Now part B, if we look at the terms, right? The first term is 2. The second term is 8/3, which is 2 2/3. Then it goes to 32 ninths, right? Which is over 3. So it's 3 5 ninths. And then this is 128/27, which is over 4. So it looks like each term is getting bigger. So it seems that this infinite series here is going off to infinity, because we're just adding a bigger number and it's just getting bigger, it looks like. But let's look at the common ratio. So again, we take any two terms and divide them, right? So 8/3 divided by 2, which is equal to 8/3 times 1/2, okay? Which is going to be 8/6, which tells us that the common ratio is going to be 4/3. And 4/3 is what? Bigger than or equal to 1. Which means that this series is divergent and that the sum, S, does not exist. And that's how you do it.